Now we begin with 11th sum, children, of problem set. 9th and 10th is included in reduced syllabus. You don't have to solve this and no question will be asked based on 9th and 10th. So 11th sum says that we have to show the point P, Q, R and S are the vertices of a parallelogram. Now if it is a parallelogram means there would be 4 sides. Okay, P, Q, R, S. P is 1 comma minus 2, Q is 5 comma 2 and R is 3 comma minus 1 and S is minus 1 minus 5. Okay, so parallelogram means what? Opposite sides are equal. So we should show PQ is equal to SR and PS is equal to QR. If this we are able to show, that means we can say that P, Q, R, S are the vertices of vertices of a parallelogram. Let us find the length of PQ and SR, PS and QR. Distance between P and Q and distance between S and R, distance between P and S, distance between Q and R. And that can be done by distance formula, children. So by distance formula. PQ is equal to, let me name it as x1, y1, x2, y2. So what will come? x2 minus x1, children? x2 minus x1 the whole square plus y2 minus y1 the whole square. So what do we get? Placing the value, x2 is 5 minus x1 is 1, 5 minus 1 the whole square plus y2 is 2 minus y1 is minus 2 the whole square, which is equal to 5 minus 1 4 square plus 2 plus 2, that is 4. 2 minus minus will become plus, 2 plus 2 will be 4 square, that would be 16 plus 16 and 32, or we can say 2 times 16. See children, 1 to 2 times 16, which can be written as 4 root 2. So we got PQ as 4 root 2. Let me write here PQ as 4 root 2. Now let us find out SR, children, by the distance formula. X3 and Y3. This is X4 and Y4. So X3 minus X4 or X3 minus X4 we will take. X3 minus X4 the whole square plus Y3 minus Y4 the whole square. So after placing the value, what we will get? X3 is 3 minus X1, 3 minus X4, that is minus 1, and that is the whole square plus Y3 is how much? Minus 1 minus Y4 is minus 5, and that is square. Now 3 minus minus will become plus, so we can write here under the root SR is equal to 3 plus 1 the whole square plus minus 1 plus 5 minus 1 plus 5 the whole square, which can be written as 4 square plus 4 square. Again we are getting 2 times 4 square, children, under the root. 1 time, 2 time, 2 time 4 square. So 4 will come out, 4 root 2. So what is SR? SR we are getting as 4 root 2. So even SR is 4 root 2. So this is our second statement, and this is our first statement. So from first and second we can say PQ is equal to SR from first and second. See, we proved From first and second, PQ is equal to SR. Now let us find PS and let us find QR. So for PS, again by distance formula, x4 minus x1 the whole square plus y4 minus y1 the whole square. What are we getting? x4 is minus 1 minus x1 minus 1 minus 1 the whole square plus y4 is minus 5 minus 2 the whole square, which is equal to minus 2 square plus minus 5 plus 2 minus 3 the whole square. That is minus 2 means 4 square plus 9. Minus 2 means 4 plus 9, and this minus 2 square means 4, minus 3 square means 9, 4 plus 9 is root 13. So we got this as root 13. Now let me rub it so that we get the place. So PS is root 13. Let it be statement 3. Let us find QR by distance formula, and that is x3 minus x2 the whole square plus y3 minus y2 the whole square. Place the value. x3 is how much? 3 minus x2 is 5 the whole square plus y3 is minus 1 minus 2 the whole square, which is equal to 3 minus 5 is minus 2 the whole square plus minus 3 the whole square, because minus minus will be minus 3, 3 minus 5 will be minus 2, sign of greater number. That would be equal to, children, 4 plus 9, and 4 plus 9 is root 13. So even QR we got, this is the fourth statement, and QR we got root 13. So from third and fourth, we can say PS is equal to QR from third and fourth, and therefore opposite sides we are getting now equal. So we can say PQ is equal to SR and PS is equal to QR. See, I have written there from first and second and from third and fourth, and therefore PQRS is a parallelogram. That means P, Q, R, S are vertices of parallelogram, children. You can pause the video and you can solve the sum. 12th sum from problem set, we have to show that PQRS is formed, PQRS which is formed by P, Q, R and S is a rectangle. We want to show that P, Q, R, S are the vertices of a rectangle, children. So what is the property of a rectangle? If I draw a rectangle here, P, Q, R and S. What happens here? PQ will be equal to RS and PS will be equal to QR. That means opposite sides are equal. Not only opposite sides should be equal, not only opposite sides should be equal, but also, this is first condition for a rectangle. What is the second condition? The diagonals also should be equal. That means we also want to show PR is equal to SQ, the diagonal. Okay. So when we can show that PQ is equal to SR, PS is equal to QR, opposite sides are equal and diagonals are equal, length of the diagonals are equal, then we can say it is a rectangle. Now here we are only dealing with the length. for a quadrilateral to be a rectangle, opposite side should be equal and each angle should be 90 degree. But here now we are not dealing with angle, children. We are only dealing with the length. So one property of length, that is opposite sides, we can do it. And how can we do it? By the distance formula. Now what is another property to be confirmed that it is a rectangle? By the length or with respect to the length. Other property is diagonal. So if the diagonals are, length of the diagonals are equal, that means it is a rectangle. Second confirmation. Okay, let us begin with by distance formula. So by distance formula. Let me write the coordinate 2, 1 minus 1, 3 or minus 5 minus 3 and s minus 2 minus 5. Okay, let us name it as xy, x1 y1, x2 y2 and x3 y3. Okay, coordinates we have assumed. Now let us use distance formula for finding PQ and SR. So PQ length by distance formula. P coordinate and Q coordinate. x1 minus x the whole square plus y1 minus y the whole square under the root. x1 is what? Minus 1 minus P is 2, okay, the whole square plus y1 is 3 minus y, that is 1 the whole square. What are we getting? Minus 3 the whole square plus 2 the whole square, which is equal to 9 plus 4, 9 plus 4. So PQ we got under root 13. So let me write here PQ as under root 13. This is my first statement, children. Now let us find SR. So again by distance formula SR. So SR is equal to, now by distance formula what will come? x2 minus x3. x2 minus x3 the whole square plus y2 minus y3 the whole square. x2 is minus 5 minus x3 is minus 2 the whole square plus y2 is minus 3 minus y3 is minus 5 the whole square. Now SR is equal to, SR is equal to minus 5 minus plus under the root minus 5 minus will be plus 2 the whole square plus minus 3 plus 5 minus 3 plus 5 the whole square, which will be equal to minus 5 plus 2 minus 3 the whole square plus minus 5 plus minus 3 plus 5 2 the whole square, which is equal to, we can say 9 plus 4, and 9 plus 4 is nothing but under root 13. So even SR we got as under root 13. So SR under root 13. So we got first statement correct, that is from first and second. We can say PQ is equal to RS from first and second. I am writing here from first and second. Now we want to prove PS is equal to QR. So let us find PS by the distance formula, children. So PS x3 minus x the whole square plus y3 minus y the whole square. Now under the root, what is x3? Minus 2 minus x is 2 the whole square plus. What is y3? y3 is minus 5 minus y is 1 the whole square, which is equal to minus 2 minus 4 the whole square plus minus 6 the whole square, which will be equal to minus 4 means 16 plus minus 6 the whole square is 36. So it will be under the root 6, 6, 12, carry 1, 4, 5, 52. So we got PS as under root 52. Let us go for QR now. Let me rub the board, children. This is statement number 3. So QR, again by distance formula, under the root QR x2 minus x1 the whole square plus y2 minus y1 the whole square. Now place the value, children. X2 is minus 5 minus x1 is minus 1 the whole square plus y2 is minus 3 minus y1 is 3 the whole square. So under the root minus 5 minus plus 1 the whole square plus minus both are minus, so will be added minus 6 the whole square is equal to minus 4 the whole square plus 36, which is equal to 4 4s are 16 plus 36 is nothing but under root 52. So PS we have already got, PS is 52, and now QR also we got as under root 52. So opposite sides are equal. So we can say PS is equal to QR. See children, PS is equal to QR from third and fourth. This is fourth statement. So from third and fourth we can say PS is equal to QR. Let us find out the diagonal length. I am going to rub it entirely as I have written from where what I have got. So for diagonal length, children, PR under the root now. PR x2 minus x the whole square plus y2 minus y the whole square. Place the value. What is x2? x2 is minus 5. Children, while placing the value you have to be very careful. Some children are finding it very difficult. See, you see x2 means minus 5. So below x2 minus 5. Then minus. Then x. So x is what? 2. y2 is minus 3. Minus the whole square. Minus both are minus, so they will be added, children. So minus 7 the whole square plus minus both are minus, so they will be added minus 4 the whole square. So what we will get, minus 7 the whole square is 49 plus 16, and 49 is 16, 6 plus 9 is 5, 15, carry 1, that is 65, under root 65. So we got PR as under root 65. Let us find the QS. So QS is equal to under the root x3 minus x1 the whole square plus y3 minus y1 the whole square. When I place the value QS, x3 is minus 2 minus x1 is again minus 1 the whole square plus y3 y3 is minus 5 minus y1 and y1 is 3, the whole square inside the root. Now when we place it, minus, first is minus and then 2, minus minus will become plus and then 1 the whole square plus. Both are minus, so they both will be added. So it will be minus 8 the whole square. Then minus 2 plus 1 is minus 1 the whole square plus minus 8 the whole square is 64, which is equal to 1 minus 1 the whole square is 1 plus 64, and that is going to be under root 65. So even QS, children, we got as 65. So here PR is 5th statement and QS is 6th statement. So from 5th and 6th we can say PR is equal to XQ. Even diagonals are equal, we have proved now. Let us write down those statements. Let me rub it. You can pause, children, and you can solve the sum. So we are getting PQ is equal to RS from first and second, and PS is equal to QR from third and fourth. Okay. Opposite sides are equal. In a quadrilateral, opposite sides are equal. Okay, it is a parallelogram, opposite sides are equal, but we still have to have one more confirmation, that is diagonals are equal. Yes, we got it, diagonals are equal. Second statement, PR is equal to SQ from 5th and 6th, but these are diagonal. Yes or no? They are diagonals, and here diagonals are also equal. So we can say, therefore, PQRS is a rectangle. Okay, here we are not dealing with the angle, we are dealing with the length of the side and length of the diagonal, and we have showed it, and therefore it is a rectangle, and hence PQRS are vertices of a rectangle. Hence proved, children, and you can pause and you can rewind and you can learn the sum as many times as you wish.